Hi, and welcome to C Programming for Arduino, a step-by-step guide. Previously, we have seen that a variable is a location in the memory that has been assigned a name, but a variable is a little more than a chunk of memory that has been given a name. When you define a variable, you must also tell the compiler what type of data is to be associated with that variable. The data type of the variable is important because it determines the two very important things: how many bytes of memory are dedicated to that variable, and what kind of data can be stored in the variable. You will learn in the coming videos that there are two basic types of data: value data types and reference data type. If the variable is defined as the value data type, then there is a very specific range of values possible. And if a variable is defined as a reference type, then there is no specific range of the values. Let's see a list of basic value data type and reference data type. It should be noted here that the Arduino supports most of ANSIC's data types with a very few notable exceptions. This column shows different data types with keywords. This column shows the size of data in terms of bytes. And this column shows the range of values which a certain data type can accommodate. These are the value data types and these are some reference data types. Let's discuss this table in detail. A keyword is any word that has special meaning to the C compiler. For example, keywords like boolean, character, integer, etc. You cannot use these words for your own variable or function names because keywords are reserved for the compiler's use only. If you do, the compiler will flag it as an error. If the compiler did not flag such errors, then the compiler would be confused as to which of the keywords to use in any given situation. If you cannot use the keywords for variable or function names, then what can you use? There are three general rules for naming variables or functions in C, which allows the use of characters small a through small z and capital A through capital Z, the underscore character, and the digit characters 0 through 9, provided that they are not used as the first character in the name. Just about everything else is not acceptable, including the C keywords. It means that the punctuation and other special non-printing characters are not allowed either. Valid names might include these examples. Using the same rules, the following would not be valid names. This is not valid as special character is not allowed. Again, in this example, a special character is used, which is not allowed. This example has a digit as a first character in the name. You can use the digit, but it must not be used as a first character of the name. In these examples, punctuation is used, which is not allowed. Special characters are used in these examples, which are not allowed. Given these limits, how does one create a good variable name? As a general rule, keep in mind that your variable name should be long enough to give you a clue as to what it does in a program, and your variable should be short enough that you do not get tired of typing it. Another convention a lot of programmers use is a variant of what's called the camel notation. Using this notation, variable names begin with a lowercase letter with start of each subword capitalized. Consider the examples. You can see that each name is starting with a lowercase letter, and each subword in the name starts with a capital letter. C could care less which style you use. However, keep in mind that it is unlikely that you will write a perfect or error-free code every time you write a program. Using variable names that make sense and are easy to read makes debugging just that much easier. Also keep in mind that C is a case-sensitive language, which means that these two are different variables. With that in mind, let's examine the common data types available for use in C programs. The Boolean data type is limited to two values or states, true or false. These two values are constants that are defined within the compiler and are the only two values a Boolean variable can assume. Let's take an example. This is the variable named mySwitch, which we have given according to our previous discussion. Boolean is the data type, and this is the value assigned to the variable. It should be noted here that a variable with Boolean data type can contain only true or false. Now consider the following code. Although we do not cover the if statement until the next chapter, you can probably figure out what is going on here. The readSwitchState function returns a Boolean value that is true if the switch is on or false if the switch is off, and acts accordingly. We should use the Boolean data type only when the variable reflects a logic state of either true or false. You really don't need to know the actual values of the compiler assigned to the two states. Although you can think of false as being 0 and true as being non-zero. So that's all for this video. We will continue learning in the coming videos. Till then, take care and goodbye.